What's up, mathematicians? Happy Monday. Hope you had a good weekend. I know I did. Um, Today happens to be a great section. It's a great day to be a mathematician. We get to um, solve some equations that contain radicals. So we get back to just some nice pure algebra today. I really enjoy this section because I really enjoy just solving equations. And it's not too difficult to do. So in this section, we're going to be solving radical equations. So they're going to have some kind of square root in them, or maybe multiple square roots. So to solve these, we rely on the squaring property of equality. It says that if you have an equation, you can square both sides and it's still going to be true. So sometimes, however, when we do this, the answer that we get doesn't work. And that's what all this is talking about. So you always have to check your solution and see if it works in the original equation. If it doesn't, then there's no real solution. And that happens sometimes, but most of the time you'll get something that works. So I'll show you how this looks. And these will go nice and quick, nice equation to solve. So once your goal is to get a radical isolated. And once it's isolated, you're going to take and square both sides of the equation. So you know that square roots and squares are opposites, so they're going to cancel each other out. And that's going to leave you with x plus 3 equals, over here, 5 squared is 25. So you see that's nice and easy to solve. Subtract 3 from both sides of the equation, and x is 22. Now you always have to check your solution back in the original equation. So let's see, what's 22 plus 3? That's 25. What's the square root of 25? That is 5. So that one checks. So you need to make sure you check though. Let's look at number 2. Again, the radical is already isolated. So you're going to square each side. And the square and the square root will cancel each other out, leaving you with x minus 5 equals 2 squared is 4. Again, add 5. Oops, not 5. X would equal 9. Plug that into the original equation. What's 9 minus 5? It's 4. What's the square root of 4? It's 2. It's supposed to be 2. So again, that one worked. Number 3, we see it is not isolated. The radical is not isolated. So the first thing we would have to do is actually subtract 6. So we get the square root of x equals negative 2. From there, the radical is now isolated, so we're going to square both sides. Let me get a different color for that. Square this side, square that side. And again, the square and square root cancel each other out. They're opposites. And x equals what's negative 2 squared. Remember, that means negative 2 times negative 2. That comes out to be positive 4. So now we go back to the original equation. Do not go here. Go to the original equation. What is the square root of 4? That would be 2. What's 2 plus 6? That's 8. It's supposed to be 4. This one did not work. So since it did not work, there is no real solution. And that happens sometimes. Just always check your solution on these problems. Number 4, I'm looking at it. The radical is already on the side of the equation by itself. It is isolated, so we're going to square both sides. Square root and square cancel each other out. X plus 5 is going to equal 9. Subtract 5, and x is 4. Let's see if that works. What's 4 plus 5? That is 9. What's the square root of 9? That is 3. That's what it's supposed to be. So that one checked. So nice and easy. You gotta love these types of problems. On the back, I just gave you the 6 steps that you're going to always follow when solving these equations. The first step is to arrange it to where one radical is by itself on one side of the equation. So you're going to isolate that radical. Then you're going to square both sides, simplify both sides, and if there's still a radical, you're going to go back through steps 1 through 3, and then you've got your equation solved, and just check your solution. So on the back, we've got a little bit tougher equations, but not too much tougher. Again, the goal is to get a radical isolated by itself. We already have that. They're actually both isolated. So we're going to square both sides of the equation. Again, the square and the square root are opposites. And over here, the square and the square root are opposites. So we're left with x equals 5x minus 2. This is like a chapter 1 type problem. So you got to love solving these things. We need to get all our variables to the left side of the equation. So we would subtract 5x. I don't know. Sorry, I'm thinking ahead. These cancel. X minus 5x is negative 4x. And that means if you divide by negative 4 to both sides of the equation, two negatives make a positive, and that 2/4 would reduce to 1/2. So we got to check that solution. Now I'm not going to find what is the square root of 1/2. I'm just going to write that's supposed to be the square root of 1/2 on the left side of the equation. On the right side, I have 5 times 1/2 minus 2, right? So 5 times 1/2 is 2.5, or half of 5 is 2.5. And 2.5 minus 2 is 0.5. So I have the square root of 1/2 is equal to the square root of 1/2. So those are the same things on both sides of the equation. So that did check. Number 6, it's much like 5. I've got a radical isolated, so I'm going to go ahead and square both sides. That's going to leave me with 7x minus 4 equals x. I'm going to subtract 7x from both sides of the equation, and negative 4 would equal negative 6x. Divide both sides by negative 6 to get that x by itself. So those would cancel, and I would have x equals 2 negatives make a positive, 4 over 6 reduces to 2 over 3. Okay, so again, not a great answer, but we can see if these kind of work out. So I would have the square root of 7 times 2/3 minus 4 on the left side. On the right side, I have the square root of 2/3. Okay, so I'm going to do the little bit of math over here. 7 times 2 is 14 over 3. And then I'm going to go ahead and make common denominators. So I'm going to put, if the 4 is over 1, you would multiply both by 3 to get 12 over 3. And 14/3 minus 12/3 does come out to be 2/3. So you see they are the same. So this did check. It worked. 7 and 8 look like each other. So let's see. I've already got that radical isolated on the left side, so I'm ready to square both things. The square and the square root would cancel, so that's going to be 4y squared plus 5y minus 15 equals, over here, remember when you square, everything has to be squared, so it's 2 squared and y squared, so that would be 4y squared, which is awesome, because when I go to isolate that y squared, you see that they cancel each other out. So what does that leave me with? It leaves me with 5y minus 15 equals 0. Nice and easy to solve. Add 15, and 5y equals 15. Divide by 5, and y is 3. And then we just have to check our work. This one's a little tougher to check, but we'll work through it. So 3 is what y is. So y squared is 9. 4 times 9 is 36. So I'm going to write that down. 5 times 3 is 15. So plus 15. And then I've got minus 15. And it's the square root of all of that, right? For the left side. So 15 minus 15, those are going to cancel. And the square root of 36, that side comes out to be 6. The right side is 2 times 3, also 6. So they both came out to be 6. It checked out. It works. Anytime you want to pause the video and try the next problem, you can, and see if you get the right answer. So number 8 is much like 7. The radical is already isolated, so we're going to square both sides. The square and the square root would cancel, giving me 16y squared plus 4y minus 28 equals, square that, and you've got 16y squared. Much like 7, those 16y squareds are going to cancel each other out whenever you subtract them. So I've got 4y minus 28 equals 0. So 4y would equal 28, and y would equal 7. So let's see, we'll check our work over here. We're going to have some big numbers this time. I've got 7 squared, which is 49, so I've got 16 times 49. I'll type that one in. 16 times 49, so 784 plus 4 times 7, so plus 28, and then again minus 28. And it's the square root of all of that. That's my left side of the equation. The right side of the equation, I have 4 times 7. All right, so again, those are going to cancel. So let's see, what is the square root of 784? Look at that, it's 28. And 4 times 7, also 28. So 28 equals 28, that checks. That is a good solution. Okay, 9 and 10, a little bit tougher, not much though. Okay, remember your first step is to isolate the radical. This radical is not by itself. There's something else that's not under the radical on the same side of the equation. So your first step is going to be to add x to both sides of the equation. So that's going to give us the square root of x plus 3 equals x minus 3. Okay. Now that radical is isolated, so we're going to take and square both sides. On the left side, it's great because the square and the square root are opposites. That leaves us with x plus 3. On the right side of the equation, we've got a binomial being squared. We have to remember what that means. It means x minus 3 times x minus 3. So that's going to have to be FOILed out, multiplied out, distributed, whatever you want to call it. So that x is going to distribute, and that's going to be x squared minus 3x. And then that negative 3 is going to have to be distributed. So that would be negative 3x and plus 9. Okay, so from this point, I need to get my equation set equal to 0. All right, so to isolate, we will subtract x and subtract 3 from both sides of the equation. So I'd have 0 equals, if I put all of that together there, that's going to be negative 7x, and that's going to be positive 6. So you should remember a trinomial like this has to be factored, and it factors very quickly, very easily. We can go straight to the 2 parentheses. We're looking for, if our third sign is positive, we adopt the sign of the second for both. So we're going to have x minus in both parentheses. What are the factors of 6 that add to 7? So your options are 1 times 6 and 2 times 3. Which of those factors add to 7? Of course, 1 and 6. And I didn't quite give you enough room here, so I'm going to come over here to the left. Remember, once it's factored, you take each factor and individually set them equal to 0. So x minus 1 equals 0. That's my first one. And x minus 6 equals 0. That's my second one. So that means that x would equal 1 and x would equal 6. So remember, with these problems, we have to check our solution. So we have 2 solutions to check this time. These ones aren't too hard to check. Let's check 1 first. So what's 1 plus 3? That's 4. What's the square root of 4? That's 2. What's 2 minus 1? 2 minus 1 is 1. It's supposed to come out to be negative 3. That one did not work. Let's check the other one. 6. What's 6 plus 3? That is 9. The square root of 9 is 3. 3 minus 6 is negative 3. That one worked. So we got 1 solution out of the 2. Number 10 is going to be similar. Again, great time to try that problem. Pause that video before I start, and then you can check to see if we got the same thing. So with 10, much like number 9, we have to isolate this radical. We do that by adding x to both sides of the equation. So I'm going to have the square root of x plus 15 equals that, in the correct order is x minus 5. So we're going to take and square both sides of that equation. That square and square root will cancel, so we're going to have x plus 15 equals, this one we're going to have to multiply out, x minus 5 times x minus 5. So think about that process. X times x is x squared. X times negative 5 is negative 5x. It's going to be another negative 5x and a positive 25. We need to set our equation equal to 0. So to do that, we would subtract x and 15. That's the fastest way to do it. We want our x squared term to be positive. It's already positive over there. So we're going to keep it on the right. So I have 0 equals x squared. All of those together is negative 11x. And that's going to be positive 10. So again, it factors pretty easily. There's no number in front of that squared term, so we can go straight to the two parentheses. Again, my third sign is positive, so I use the sign of the second for both. Remember, if that third sign is negative, you use 1 plus and 1 minus. But this time it's positive, so x minus and x minus. What are the factors of 10 that add to 11? Again, the easiest one, 1 and 10 adds to 11. So we take each factor and individually set them equal to 0. So it looks like x would equal 1 and x would equal 10. And then we check them. Let's plug in 1 first. 1 plus 15 is 16. The square root of 16 is 4. And 4 minus 1 is 3. It was supposed to be negative 5. That one did not work. So I bet 10 does, but let's check just to make sure. 10 plus 15 is 25. The square root of 25 is 5, and 5 minus 10 is negative 5. That one worked. So that's a fun one. You got to enjoy those ones. 11 and 12. These ones are the toughest type of problem because you just have to do it twice, but it's actually not too bad either. So again, we've already got a radical isolated. We can't isolate this radical, but we've got one of them isolated, so we'll go ahead and square both sides. That square and that square root will cancel, leaving me with x minus 4. This one we have to think of the square root of x minus 2 times the square root of x minus 2. It's got to be distributed. Okay, so what's the square root of x times the square root of x? That is x. What's the square root of x times negative 2? That's negative 2 square roots of x. What's negative 2 times the square root of x? Another negative 2 square roots of x. And then negative 2 times negative 2 is positive 4. Okay. So you'll see I still have a radical in my problem, so I need to isolate it. So I will start by moving non-radicals to the left side of the equation. So I will move this x over there by subtracting x. I'll move this 4 over there by subtracting 4. So subtract x, subtract 4. Those cancel, those cancel. Those also cancel. I've got negative 8 equals, those are like terms. What's negative 2 square roots of x minus 2 more square roots of x? That's negative 4 square roots of x. And then to get that radical isolated, I have to get rid of that negative 4. What is that negative 4 doing? It is multiplying, so to get rid of it, we would divide by negative 4. And negative 8 divided by negative 4 is positive 2. And then you see, that's really simple. The radical is isolated, so we square both sides, and x equals 4. So we got a solution. Let's see if it works. What is 4 minus 4? 0. What's the square root of 0? 0. Over here, the square root of 4 is 2. What's 2 minus 2? 0. So we have 0 equals 0. That is true. That works. X is 4. Might pause this and try it also. Otherwise, here we go. So this radical is isolated. So I will go ahead and square both sides. Okay, this one's got to be FOILed out like we did here. So you might write it down. Square root of x minus 4 times square root of x minus 4. So if I FOIL that out, square root of x times the square root of x is x. Square root of x times negative 4 square roots of x, same there, negative 4 square roots of x, and then negative 4 times negative 4, positive 16. On the right side, the square and the square root cancel, so we got x minus 16. Now I need to get these radicals by themselves, so anything that's not a radical is going to get moved to the other side of the equation, so that would be subtracting x and subtracting 16, and subtracting x and subtracting 16. Those x's also cancel once again, so it looks like I have negative 8 square roots of x on the left side when I put those together, equals negative 32. Divide by that negative 8, and it looks like the square root of x would equal positive 4. From there, just one small tiny little more step, square both sides, and x equals 16. Let's check that solution. What's the square root of 16? It's 4. What's 4 minus 4? That's 0. 16 minus 16 is 0, and the square root of 0 is also 0, so it checks, it works. So, great day. Gotta love just solving some good old-fashioned algebra problems. Let me know if you need any help. Reach out to me on email, Google Hangouts, whatever you need. I'll be there for you. Have a great day, and I'll talk to you later.